So for clarity, let me create the documents first. Doc insert 1 is equal to new document, which is going to take username insert 1, and I'm going to append the password. PWD insert 1. Similarly for insert 2 also, I'll be doing the same. Insert 2, and the password is going to be insert 2. Now for update, we just need to set the value for the update. This is for doc update. The original document, it's going to have the username. Let me get the username from here. The username is going to be admin2. The updated one, I mean the new one, is going to have a username admin to modified, and the command execution for setting this is going to be different here. Update command, new document, we have to provide the set operator here, and then the document name. You might have already known about this, a set operator. Now we did an update. Just to recall what I have did, I have created an original document. This will match the query, and the new document which is going to replace this. But do remember that we need to use a set, or it is going to just change the structure of the document with the new one. So I have used a set operator. It has to go in the form of document. So one more document I have created here, and then provided the new one to this. And finally delete. Delete is going to be very easy. I'm going to delete this one, that is with admin3. Document delete. I'm going to delete this admin3. So we got two inserts, a single update and a delete in a bulk write. Now it's time to create a list. Array.as list. This is the one we are going to use. The complex part is going to be here. New insert one model and the document. The document is doc insert. So the next one, it's going to be doc insert 2. Oops. We are going to send this list as a bulk write. Third one is little complex, because we'll be using the update one model. Update one model, the filter and the update. The filter is the original document. The update is going to be the update command that will have the new document with the set command. Now we have done 2 inserts. We have prepared the list for 2 inserts and 1 update. New delete one model, and this is going to be docdel. So let us see it again. We have created a list with 2 insert models, 1 update model and 1 delete model. For update model, this is the filter query. That's the original document which admin 2. I'm going to replace that with admin 2 mode without changing the structure. So I have used set. Now to the key method, that is collection.bulkwrite. And this is the list we are going to write. The list of data. Let us check the collection status before and after. This is the status before bulk write. The status after bulk write, it's going to be different. So we got 2 inserts, 1 update and 1 delete. Admin 3 has gone, which we have deleted using delete model, delete one model. This shows how bulk write happens. So let me walk through this again. For bulk write, we need to create a list of models. For that, we have prepared the documents initially. For update, we have a original document which will be acting as filter. The second one is a command with the set operator, which is going to replace the original one with the new document. The third one is for deleting. For that, we have used delete one model. We created a list and then we have passed the list as a parameter to the bulk write method in collection class. So this has changed our existing data in the collection successfully. So this is how bulk write works. With this, we have seen all the demonstration topics. We have listed the databases. We have looped through a collection to display its documents. We created a new collection. We did insert single, insert many, and similarly delete and delete many. We dropped a collection, we dropped databases. We used find, and we have used classes under the model package, filters, sorts, and projections. We did update. We have seen about run command. We have seen how to upload a document using GridFS. Finally, we have seen about bulk write. With this, we have seen the demonstration of using Mongo Java driver with MongoDB. C# with MongoDB. This is a fairly easy process. The API is very clear and concise. These are the key steps involved. The first step is to install the package, that is the MongoDB driver, using the NuGet in Visual Studio. The second step is to use the Mongo client class. This is used for connection. The third step is to use one of these classes, models collection based on document filters, to do the CRUD operation. As you know, there are 2 ways to install NuGet packages. Either you can take command line options or you can do visually using the context menu. For our demonstration, we'll be seeing these. We'll be listing databases, listing collection contents, we'll be creating new collections, we'll be inserting, we'll be finding, we'll be updating, deleting, we'll be limiting, sorting, filters, and we'll be doing the projections. And finally, the important ones, bulk write, run command, and GridFS. The link mentioned here, that is the GitHub link, has complete details about the C# driver. Let us visit that first. Search for MongoDB C# GitHub. This is the link. This page has all the releases, references, and APIs for the C# driver. Google for MongoDB C# GitHub. Click on the search result. Click here further. This page has details about the various releases of this C# driver, details about the packages involved. On clicking reference, it has a great tutorial about how to get started. Installation steps are given here. Under quick tour section, you can see details about the common operations and the CRUD operations. For instance, details about making a connection, getting a database, getting a collection, inserting a document, finding a document, all those details are available here. Under admin quick tour section, details about the admin operations are available, such as how to create a database, how to drop a database, how to create a collection, drop a collection. All those details are available under admin quick tour. In our demonstration list, we are going to start with the first three, that is list databases, list collection contents, create a new collection. These three we are going to see now. Under Visual Studio, right click here to install the necessary driver. Click Manage NuGet Packages. Search for MongoDB. It lists you two drivers, MongoDB driver and the old one. Click on this. Click Download. So there will be three packages installed. Let us cross verify here. MongoDB driver, Mongo driver core, and MongoDB JSON. So all three are same. Clicking OK. We must see the drivers in our references. You can see here in the references, MongoDB Bison is available, MongoDB driver is available, and MongoDB core is available. This is the easiest way to install a NuGet package, or you can take the command line option as mentioned in the slide. We are going to see our first set of demonstration, that is to list databases, list collection contents, and then to create a new collection. I'll be using a separate class for this. The key packages needs to be imported first. That's MongoDB.driver and using MongoDB.bison. First step is to create a Mongo client, which is going to connect to the local host. Next step is to list the databases. Client.list databases, that to array list, sorry, to list. Now we have the list of databases. The next step is easy. We just need to loop through this one to get the available databases in the local host. In the main program, I'll be calling this one, that is demo set1 dot main. On running this, we must see the list of available databases. These are the databases available: DB demo, demo PHP DB local, test C#. Let me refresh this one. So we have done our first sample. So list databases is over. The second one in our list is to list the collection contents. That's very easy. Let me client dot get database. I'm going to use this one, demo PHP DB. Under this, I have a products collection. Get collection. Name is products. Yes. So here it needs to be a JSON document type. Now let us convert this zone into a document list. That's easy. Doc list equal to collection dot find new JSON document dot to list. Doc list. Let me run the code now. We got the complete collection contents over here. What we have done is, using client, we got the database and we got the collection of type JSON document. Then on that collection, we have done an empty search that's using find method. We converted the result to a list and we looped through the list to get our collection contents. Let me cross verify this one. So GoPro. So the results are similar. 9 objects we got. Let me cross check the result. We got 9 documents here. And here too we got 9 documents. We have successfully finished our second assignment, that is to list collection contents. The third step is to create a new collection. Let me create a database as well as a collection. That's very easy. So this is what we did is for showing collection contents. The next one is for creating new DB and a new collection. Let me copy the same code. Client.getDatabase. The database name is going to be C# DemoDB dot create collection. Please note that this database doesn't exist. So when you use get database for a database which is not existing, it's going to create a new one. The collection name is going to be products. So we have done. Let me run the code. Now we must see a new database and a collection created. Clicking refresh. C# DemoDB is created. C# DemoDB. Under that we must see a collection by name products. Yes, we got. So this is how we can create a new database as well as a new collection. We have successfully seen the top 3 in our demonstration list. Next we are going to do a insert single and insert many. To demonstrate insert, I'll be using a separate class. So let me create that here. Insert demo. I'll take some code part from our existing example. I'll be using some existing code portions. Mongo client, then the connection to the database and the collection. In our case, do remember that we created a database by name C# DemoDB. I'll be connecting to that, then to the products collection under that. The next step is to insert one. For that, we need to create a bzone document first. Dot add the fields. Category string value is going to be electronics. Then again I'm going to add few more fields. Key value pairs, The name of the product, it's going to be the Amazon Echo Speaker. Price, it's going to be around $180. Now we have created a JSON document. The next step is to call insert one function in the collection, insert one, and then the document name. Now let me call this main function in our main program. On running this, we must see a new record inserted. Refresh. Yes, we got one record. Let's see the records. We have three fields now: category, name, and price. A single insert has been done. That's what it's called as insert one. The next step is to do multiple inserts. For that, we need multiple documents in a list form, and then we'll be calling the insert many like this. Insert many. Okay. One, that's two, that's three. Category is electronics. Price is going to be $32 or $33. It's command 37. The next one is mechanic kit. Price is around $90. And finally, it's kitchen timer. Price is around $10. Let me add all this to a list. The list of docs is going to be new. List of JSON documents. List of docs dot add doc1 doc2 doc3. Just need to change the same here. doc1 this is doc2, oops, doc2 and doc3 followed by doc3. It's going to be list docs. This will do multiple inserts for a single method call. Let me run this one. We must see multiple records now. Yes, we got all the records what we have done as a batch operation in insert many. So this is how insert one and insert many works. The next in our list is find and find with query. We'll be knowing more about find with query when we are going to use that with limit, sort, filters, and projections. So now let us see a simple demo using find and find with query. First up, I'm going to create a separate class for find. I'll be using the code portions from the previous examples. We are going to search in this database and in this collection. Now on this collection, I'm going to do a find query. It's going to take an argument of a document, that's based on document. Initially, I'm going to give an empty document so that I'll be getting all the records there. To list is the simplest way, or you can use cursor also. I'll go with list currently. Do a code formatting. Oops, I haven't called this in the program. Now we got all the documents in that collection. Now let me introduce a condition so that it's going to filter based on price. Let me give the value as 90. Price 90. On running this, we must find items with only price 90 is listed. This is how find with query works. We'll be seeing more about this while we are going to see about limit, sort, filters and projections using builders. So our next topic is going to be on this for. Let us start with limiting first. It's very easy. You just need to call the limit method here, and the number of rows, the number of documents need to be displayed. In my case, I'll be getting 3. Oops. Prior to that, I want to take out this condition. So we got 3 listed here. So this is how limit works. The next step is to have sorting. For sorting, we'll be using builders. That's very easy. So builder equal to builders. It's going to be here. Based on document dot sort. That's it. Variable sorting is equal to, on this builder we are going to call the ascending method or the descending method. We have ascending. I want to list the prices in ascending order. I will take the column, the field name here as price. So this must give us the result in ascending order. So we must pause this sorting, call the sort, and then pause this. That's it. So we must get the top 3 least priced products. This is the result. This is how it is in the DB. So 10 is there, 10 is there, and 33 is there. One more 33 is there, but we have limited the results by 3. So we got it. Sorting works fine. The next step is to have projection, because as you can see currently You get the ID field. I want to filter this ID field and the category field. I just want only the name and the price. It's a different builder. So builder projection is builders. Builders based on document type dot projection. That's done. Now the next step is to do the projection configuration is going to be builder underscore project dot. We got include and exclude. I'll be including the price and the name. I'll be excluding the ID column. So we got a new projection. Let me take out this sorting now. Want to do a projection. So we got project method. I'll be pausing projection config. On running this, we must see only the required columns get displayed here. So name column we got and the price column. We have excluded the category and the ID column. So this is how sort, projection and limit works. Now let us move to the next one. In our demonstration list, we have seen about limit, sort and projections. Now let me show about filters. Filters is very easy, similar to projection and sort. Let me copy this line. Filter, and here it's going to be filter. Filter query is equal to. You can see different methods are listed here: greater than, less than, equal to, all those things. And for this demo, I'm going to use a greater than. You just need to give the field name first. Field name is price, and I want to get products with price greater than 50. So instead of project, it's going to be filter and this filter query. So our find method will use this build filter to filter the documents which have price greater than 50. I'm running this. We got 3 products which have price greater than 50. Let us cross check that. 1, 2 and 3. Yes, that's right. So this is how filter works. The only difference is filter needs to be given in the find method, whereas for project and sort we have separate methods. Now next topic is update one, update many, delete one, delete many, drop collection and drop database. These are very easy. Let us do that. Let me create a separate class for that. Let me copy some code portions from the insert demo. So basic setup is ready. We are getting the collection using the Mongo client, and the collection name is products. Now the demo is update 1. So let me create a separate class for this. Update delete a demo. And I'll take some code portions to speed up. So we got the collection now. Now we are going to see about update 1. It's very easy. You just need to create a filter and then you need to set the value. So create a filter and set a value. That's it. So you know about creating a filter. We have seen about builders. So it's builders based on document. So I'll be changing the value of this 33 to 40. So that I'm going to do here. The filter is going to be on price, 33. So to update it, it's very easy. Builder underscore update. It's the same. Update will be called here, and the set method. Prices 40. Now it's simple. We just need to call the respective method. That's it. So on this collection dot update 1 takes 2 parameters. The first one is filter, and the second is the update statement. I'm going to change this. Run it. So I need to see the changes here. Yes, as you can see, the 33 got updated into 40 in one document, not in multiple documents. So in case if you're going to use update many, it is going to update multiple documents. For instance, I have 2 documents with price 90. I'm going to change that as 95. The difference is here I'm going to use update many. So we must see multiple documents must get updated now. 1, 2 we got. So we got both the documents updated. So this is how update menu works. It's very simple. Just remember to call the filter and then the update set. Now to the delete. Delete, it's going to be the same, only the thing is it takes a single argument instead of two. So I'm going to delete one where the price is 10. Same filter, but this one is for delete, price is 10. Next step is collection dot delete one, the condition. Let me comment this portion. We have two documents. After this, we must see only one document. Done. Yes. One is gone. Oops. Yeah, right. It's right because it hasn't deleted two documents, because I mistaken that it has deleted two documents because I have given here only delete one. So in case if I am going to give delete many, it's going to delete both the documents. So let's do that also. Delete many, prices 95. After this, we must not see price with 95. Gone. This is how update and delete works. We have seen about delete many, update and update many. So for update, just remember that you need to call update and then set. For delete, it's very straightforward. You just need to give the filter. That's it. The next one in our list is to do a drop collection and drop database. This is very easy. Let me create a separate class for this. The API is very well organized, so things are very easy. Let me paste some code portions from the previous examples. To drop a collection, you just need a tilde the database. So you got the database and then do a drop collection on that. db dot drop collection. Our collection name is products. Let me cross verify it. It's products with 4 records. On running this, we must see the collection vanished. Here it is, drop demo. Refresh here. Collection is gone. Now to the drop database. That's very easy. We just need till client only, the layer above the database. So drop database. That's it. Let me take out this. Running this, we must see the database dropped. So database is gone. This is how drop collection and drop database works. For a drop collection, you just need to call the drop collection method in the database, whereas for dropping a database, you must call the drop database in the client. The next one in our list is bulk write, run command, and GridFS. Let us start with bulk write. It's very interesting. So a new class to do that. Bulk write a demo. Let me copy the code base from here. Oops. If you see the API for the bulk write method, it takes write model as a parameter. So let's create an array of write models, and for a write model, this is the API of that, and you can see the inheritance hierarchy. There are many models under this. So if you take insert one model, we can add a insert one model to a write model array, and then we can feed that to the collection.bulk write method. So the first step is to create insert models, then we will create update models, then finally we'll create delete models. So this document is good for insert model. Let me take down this here. So this is doc1 and this is doc2. This is going to be some dash prices $2, where insert model 1 is equal to now insert one model. The document is bsum document. It's going to be doc1. Let me create the second one. So this is model 2, it's going to be doc2. So we created 2 insert models and 1 update model. I'll be using the same. Update action, this is going to take the doc update here and the set. Now let us create a update model. It's going to take the filter parameter. Come on, this update action. Oops. Done. So we have created a update model. Let me add one more product here so that deletion can be done easily. Top 3. It's going to be Casio Wave Scepter prices $59. There is doc 3 here, insert model is 3. So for delete model, I'll be using the same to delete it. So based on doc3 filter for delete, prices 59, which will be matching the Casio web sector. And where delete one model is equal to new delete one model based on document. The document name is doc3 underscore filter delete. So we got all the models now, totally 1, 2, 3, 4 and 5 models. The next step is to add that to an array. That's very easy, where write models is equal to new write model. It's going to be of based on document, it's an array. Here we'll be giving all the models: insert 1, insert 2, insert 3, model 1, insert model 2, insert model 3, update model, delete one model. The next step is to call the collection dot bulk write, bulk write, and we need to pass this as an parameter here. So let me recollect what I have done till now. We created 3 BSON documents for insert models. So all 3 are linked here. Then we created an update model. Update model was a little bit complex because we need 3 documents for that. One for filtering, one having the update value, and the third one having the set. So that's done. And again we used filter delete to create a delete model. So this is B-Write demo. So let me run this one now. So we must see the new collection created, database created. Yes, we got view documents. Perfect. So we did 3 inserts, so out of which one is deleted because we have given in delete one model to delete the wave scepter, that is Casio wave scepter. This might have got deleted. This is deleted. Because of this price 59 we are deleting, and we got an update. The price was 2, we are updating by 1, so we got an update successful. Similarly the inserts are also successful. This is how bulk write works. Let me recollect what we have done. It may seem a little bit complex, but it's very easy. In the first step you just need to create the necessary documents, BSON documents. Once that is done, select the model which you are going to do. For instance, you can select insert model, update one model, or update many model, or delete one or delete many models. Then using the documents you have, create these models. Update model is little bit challenging because you need to create 3 documents. The first one is for filtering, the second one is the real update, and the third one will have the set operator with this update document. So once update model is done, similarly you can use delete model, which is very easier because you just need the filter condition. So you need a single document. Once this is done, create a write model array. All the models have been inserted, and just simply call the bulk write method. It will write all the models whichever you have done here. This is very useful when you're going to do a batch operation, and you can reduce a network overload. The next in our list is to do a run command. This is very easy. We have seen about bulk write that is used for batch operations. Now we are going to see about run command. This is a very simple but a very handy method for executing database commands against the database. If you search for MongoDB commands, you'll be finding this link, database commands MongoDB manual. Under this commands page, the commands are grouped under 4 different categories. We are going to use this command to see the storage utilization of our collection. We are going to call the db.run command. The command has to be in command format. As you can see here, the syntax is in command format. We can create a bison and then we can cast to that. In the command, on clicking that, you'll be able to see how the syntax works. We'll be giving the command and the string. So we'll be doing the same. So this is call stats command. The name of the collection in our case is products collection. We're going to give here bison O. So let me do a cast here. Command of type. Oops. Console.writeLine. Or let me write it. JSON. So what we have done is we created a bison document with the command and the collection name. Then we have casted that to a command object and we have executed using the run command method. On running this, the details are here. This storage size is important, which is given over here, and this is our collection name. So this is how run command works. You can use this for variety of purposes, for database monitoring, all those stuffs. The next one in our list is a GridFS, which is one of the interesting among all this. So this helps us to save images or videos to our database. Let's do a sample on that. For GridFS, you need to install a package. Just Google for MongoDB GridFS or just GridFS. So this is the one you need to install. It's already there. So once this is done, you'll be able to see the namespace using MongoDB.driver.gridfs. This namespace will be available only after doing the installation. Now let me copy some code portions. And similarly for this. One of the key classes we'll be using is GridFS bucket. So this is the API of that class. This zone we are going to use. So where is equal to new GridFS bucket. As you can see here, the first argument is a database, so we can easily give a database name here. The second one is a GridFS bucket options. Let us do it later. Now we got the bucket. In bucket we got two upload methods. One is upload from bytes and upload from stream. If your file size is huge, go for upload from stream. If your file size is normal and within your RAM limits, because this one is going to load the entire content into your program memory, so you can go for upload from bytes. So I'll be using the first one, upload from bytes. The first parameter is the file name which is going to be saved in the database, and the byte source. So to get the byte source, let me use a file class. So that's under system.io.file.read all text. ctemp. Let me locate the file first. It's langs.jpg. langs.jpg. Yeah. So this is going to save in a byte array. The file name, in my case, I'm going to give a name like langs info. Source is this. Read text. Read all bytes. Yes. So the issue is fixed now. What we have done is we created a GridFS bucket class. We have read the file contents, and then we have used upload from bytes method, not the upload from stream method. We have used upload from bytes because it's a small file, and then I'm passing the parameters. Let me run it again. Done. Let us cross verify in the database. Refresh. We got the files. Langs info is the file name we have given. View file. I'm using it from view for this. So we got the langsinfo.jpg file uploaded in the database using GridFS. So similarly, you can use find and download methods to download from the database. So this is how GridFS works. It's very, very simple but very useful. With this, we have seen all the topics in our demonstration. The important ones are bulk write, run command, GridFS. PHP and MongoDB. It is very easy to work with PHP and MongoDB. The only challenge currently is that PHP has 3 different paths. The first one is PHP 5.x, the second one is HHVM, and the third one is the newly released PHP 7. As you all know that PHP 5.x has a wider adoption and it is live in many production systems, though it lags in performance. Mainly due to the performance reasons, the PHP community adopted to HHVM faster and there has been many migrations to HHVM. But please note that PHP 7 has performance as similar to that of HHVM in all the areas except in WordPress PHP. But I hope in next iterations they will be catching up HHVM in that also. So we have 3 different installations to be done for 3 different paths. We'll be sticking with the most widely used, that is PHP 5.x, because as you all know that PHP 5.x is compatible with PHP 7. We'll be using PHP 5.x for a demonstration since PHP 5.x is widely used and migration to PHP 7 is very easy from PHP 5.x. There are 2 different types of drivers available in PHP.NET for MongoDB. The first one is the legacy driver, the not recommended one, that is Mongo driver. It's very simple to work with Mongo driver, but it is not recommended. So we'll be using the latest one, that is a MongoDB extension, PHP MongoDB.dll. In addition to that, we'll be using a MongoDB library to make our work easier. MongoDB library is a higher level of abstraction over this MongoDB extension. So you need to install these 2 things in your system. For the installation, you need to use PCL or direct download from PHP.NET website. And for the MongoDB library, we'll be using Composer. It's very easy. We'll be seeing more about the installation process in our demonstration. We'll be doing the following steps for the PHP MongoDB demonstration. The first one is we'll be installing the MongoDB extension from PHP.NET. Either you can use a PCL or you can directly download the DLL from PHP.NET. In the second step, I hope you must be all having this one, either XAMPP, WAMP or MAMP in your systems. In the third step, we'll be configuring the extension in the PHP ini file so that this PHP MongoDB.dll is in the extension list. In the fourth step, we'll be installing Composer and we'll be using Composer to install the MongoDB library. And in the fifth and sixth steps, we'll be locating the autoloader PHP and we will be including the path in our PHP scripts. So these are the 6 simple steps we are going to do for the installation and configuration. It's very, very easy. Under Getting Started section, 2 installation steps are given. The first one, we'll be using PECL for installing. This is for the installation of MongoDB extension. For the second one, you need to use Composer. You can use PECL or you can directly download from PHP.NET. So visit PHP.NET, search for MongoDB. So this will take you to the extension page. As you can see, database extensions, vendor specific extensions, MongoDB. Click on the installing configuring section. As mentioned earlier, you can use PECL for installing this extension, or you can directly download the DLL. Click on this. There is a mistake here, that is this extension has to be PHP MongoDB.dll, not this one, because this DLL refers to the legacy driver. So for extension, we'll be having PHP MongoDB.dll. Click on this. On clicking the DLL, will be listed with thread and non-thread safe options. Click on the thread safe x86. In the zip file, you'll be able to see the PHP MongoDB.dll. This has to be kept under the extension directory, and this entry needs to be added to the php.ini file. In our demonstration list, the first task is to list the database. So let's do that. The first step is to add the autoload.php of Composer. In my machine, it is located under C user Sorgo vendor. Sorgo is a username. So let me copy this path. The next step is to use the manager. For manager, it's very easy. You just need to import this one or use this package driver. So under this, we can get the manager class. Manager is used for connection. New manager. Here we have to give the server URL. We have a MongoDB instance running in port number 27017. Now manager is done. The next step is to issue a command. To check the API for this command, you can search for MongoDB driver command. PHP.NET reference will be listed. So here you can see the examples and the syntax for command. So it's an array. Here we'll be giving the MongoDB command. To learn about MongoDB commands, just Google for MongoDB commands. Here 4 sets of commands are given. We are going to see about listing databases. So list databases is the command we are going to use here. That's done. The next step is to execute the command. For this, we are going to use the execute command method in the manager. Execute command. The first parameter is the database name. So that's admin database. The second parameter is a command. Let's see about the syntax of this. This is the API for execute command method, which is going to return a cursor. It's going to take 2 parameters, that's a string and then a command. String will have the database name. It's going to return a cursor. Let's dump this cursor to see what it has. I have copied the result to a separate file. We have to extract this one. For each cursor as result and again one more for each. This is for result. We have databases. Let me cross check that. Yes. Yes. DB name. It's going to be DB name. Come on. So let me comment this one out and do a code formatting. On running this, we must see the databases names. Class SDD class cannot be converted to a. I need to check this output here. Yeah, this is name. I missed it. Let me add this one. Now we must get the database names listed. Yes, these are the 4 databases currently available in the local server. Let us cross check the same. DB demo, demo local, and PHP MongoDB. So all 4 are there. This is how to list the available databases. Let me recall what I have done. In the first step, I have included the autoload.php. In the step 2, I have used manager and command class under MongoDB driver package. Using manager, I have connected to the local host. And in the command, I have issued list databases command. For the command syntax, please do Google for MongoDB commands. It will take you to the reference of all the commands, where the commands are grouped into 4 separate sections. Then I have called the execute method in manager to execute this command against the admin database. And then I have just looped through the cursor to get the database names. Next one in our demonstration is to list the collection contents and then to create a new collection. So we'll be doing these 2 together, list collection contents and then to create a new collection. Let me create a new PHP file for that. The steps are going to be same. Contents. To list the collection contents, let me take the code part from here. So we have manager now. I'm going to use the database class, which is going to be under use MongoDB database. It's going to be mgr comma the database name. Let me get the database name. It's db_demo. Now we have the database. The next step is to have the collection. So $db. The collection name is call user details. I'm going to do a find in this collection. Currently without any queries, so it's going to list us all the elements in that particular collection, which is in turn is going to return a cursor. We got the cursor, then for each $curs as $doc. That's going to be there. Let me get the fields. That's username I'm going to list here. So that's it. We must get the usernames. Yeah, I need to run this one. We got the username Bob. This is the only one document in this collection. If you want to change a collection, you just need to give the collection name. It's user ID here. I just changed the collection name. To list a collection under different database, you just need to give the database name over here. For instance, demos the database name. The collection name is tbl_login, and the field name is user ID. So instead of username, I'll be giving user ID. The results are matching. Let us recall the steps what we have done for listing the collection contents. We use the manager class to connect to the server, database class to select the database, and then we have selected the particular collection in the database instance. And finally, we have used the find method to list all the contents of the collection. So it's pretty simple. Let us move to the next one in our list, that is to create a new collection. Let me do it here itself. This is for listing collection contents. I'm going to create a new database, that is demo_php db. Under this database, I'm going to create a collection. Create collection. The collection name is going to be products. Let me do a var dump of this. It's a simple one-step procedure where we have connected to a database which is not existing, and then we have called the create collection. Now let me run this one. It's okay, it's created. Let me check in MongoBooster. Yes, database is created, and then it has a products empty collection. We have just seen how to create a new collection. We have created a new database, demo PHP DB. Under that, we have created a collection by name products. Now the next step is to do a insert single and insert many. Let me create a new PHP file for this. The first step is to have the require. Let me copy this from here. In the second step, I'm going to use the manager. So let me copy this particular code. Manager is same, database is same. We are not going to create collection. We are going to just select the collection. The collection name is products. Now we got the collection. The next step is to insert in this collection. Prior to that, let me check the data in the collection. I mean the documents in the collection. So we don't have any data in the products collection. So let me insert a few documents here. Let's insert one. I'm going to give an array. It's going to be the product name. Name is going to be drone parrot. And price is going to be $300. We can even get the result here like this, and then put a var dump of the result. We don't need command. Let me delete this one. Let me run this. We got the insert ID too here. So it's successfully inserted. The next step is to do an insert many. That's going to be very easy. Let me comment out this one. Instead of insert one, I'm going to use insert many. The product list here, the name is GoPro Hero, price is $215, PHP Storm IDE, price is 19. I just need to add one more square braces. Just remember that this is the main difference. For insert one, we'll be having a single square brace at the beginning and end. Here it is array within array, so we'll be having two square braces. On running this, we must see two new values. Yes, so insert many is successful. The next step is to do a find with query and a plain find. Let's do that. Let me copy the common portions. Now we have the collection. We just need to do a find in this collection. to return a cursor. The next step is to loop through the cursor. On running this, we must see the names. We need to run the find demo. So drone parrot, GoPro, PHP Storm IDE, GoPro, and PHP Storm IDE. That's because I ran insert demo twice, so the duplicate values are here. Results are same. The next step is to filter the result. That's easy. The find query, we are going to filter using the product name. It's going to be a document, so array brace is required. Name, it's going to be PHP Storm IDE. Let me run this one. I need price. Running this, it must list the price. Yeah, it's 1919. This is how we'll be filtering. The next step is to see about sorting, filtering, and projections. That's very easy. So for this, I have created a test data. Here introduced a new category by name IDE in our products collection. The IDEs with their price. And similarly, I have updated the PHP Storm IDE's values. I have added a category IDE field here. Executed this one. Currently, my collection looks like this. It has a category called IDE with price, and different IDs are listed here. So we'll be using this simple collection with minimal records. First, let me select the category. And run this. Let me list both the name and price. This is the one. Next step is to limit the number of records shown. That's very easy. You just need to call the limit here, and then let me make it as 3. So we got only 3 results. For sorting, that's very easy. Just sort here and add another array. The field name is going to be the price, and the sorting order is -1. On running this, we must get the top 3 priced IDs. So Zen Studio, it's 189, PHP Designer is 99, and Rapid PHP is 59. So this is how sorting and limiting works. Now let us see about projections. Projections are very easy. Let me use the same array like this. You just need to say the projection and then the columns you need. In my case, the fields I need is the name only. It has to be 1. Square braces is ending here. We have added projection. It's going to throw an error because price is filtered out. If you take this out and then execute this, it's going to give you both the columns, I mean the name and price. If you include the projection, it's going to throw an error because price is filtered out. We need only the name column here. Let me run it again. Okay. So that's how we got undefined index price. We got the names listed, as you can see here: Zen Studio, PHP Designer and Rapid PHP. So name got listed and not the field price. Let me comment out this and show you how the var dump looks. Var dump of the doc. We have only the name in the var dump. If we are going to take this one out, it's going to show all the fields. So we got name, price, category, all the 3 fields. If I'm going to introduce projection, it's going to have only the name field. This is how projection works. Now let us see about update and delete many. Separate PHP file. Update demo. So till this it's common. Let me copy this portion over here. In this collection, we are going to call the update1 method, which in turn is going to take 2 arrays as a parameter. The first array is for filtering the values and the second array is to set the values. For filtering values, instead of VStudio, I am going to change the name as Visual Studio. VStudio is the name. The name is VStudio and I'm going to set the value here using the set operator. The name is Visual Studio. So that's it. If you want to save the result, you can get the result here and then do a dump of that. On running this, we must see the record updated. It's true. View documents. Yes, previously it was V Studio, now it became Visual Studio. That's how update 1 works. Let's do the update many here. The name is going to be PHP Storm IDE. I'm going to change the name as JetBrains PHP Storm IDE. Instead of update 1, it's going to be update many. That's it. Let me comment this on out. So it's true. Let's check in the database. You can see multiple documents got updated. JetBrains PHP Storm IDE here too. We have seen about update 1 and update many. Now let us start with the delete 1 and delete many. Create a PHP file for that. Delete demo. The code is similar to update code, so I'll be copying this portion. Let me comment out this one, that is update many. I want to have this update 1. Now I'm going to replace update 1 with delete 1. It just has a condition. The condition is name is Visual Studio. Let me cross check it here. We have a document with name field as Visual Studio. So that's what a delete 1 is going to do. It's done. Let me check it again. It's gone. Now let us see about delete many. Instead of update many, it's going to be delete many. The query criteria name is PHP Storm IDE. Yeah, there is a spelling mistake. Let me correct that. It's delete many. Successful. I'm running this. Yes, the records, the documents having name JetBrains PHP Storm IDE is gone. So this is how delete and delete many works. We have seen about delete 1 and delete many. Now let us see about how to drop a collection and drop a database. That's very easy. I'm going to use a code which we have used previously for creating a collection and a database, because here I want to create a new database and a new collection. We know that this is going to create a new database and new collection. I'm going to just change the database name as demo drop. On running this, we must see a new database there. Let me refresh this one. We got the new database with the collection products. The next step is to drop the collection. So $db. The collection name is products. Yeah, products. $call drop. So this will drop the collection. Let me run this one. Refresh here. The products collection is gone. Now to drop the database, that's easy. Again, you just need to call the drop method, but on the DB. Done. Refresh. It's gone. So this is how a drop for the collection and drop for the database works. With this, we have seen about all in the list except a bulk write, run command, and GridFS. Let me start with bulk write. New file. It's very easy. I'll be using the code portion from our existing examples. We'll be using the bulk write class. Use MongoDB /driver /bulk write. Creating a new instance of this. Bulk equal to new bulk write. Now we are going to use the insert, update, and delete methods in the bulk. To start with, I'm going to do an insert. Category, IDE. Oops. Name, it's going to be PHP Storm IDE. Come on, price $19. Similarly, I'm going to insert Visual Studio here with the price as 0. Then update. As you know, update has two array parameters. The first one is for filtering. So let me check the existing record here. NetBeans. The name is NetBeans here. Category, it's the same. I just need to do a set here. $set. Update is done. So NetBeans will change into NetBeans IDE. And finally, I'm going to delete this one. That's a drone parrot. Name is libraries. So we have 4 operations, 2 inserts, 1 update, and then 1 delete. In the next step, I'm going to use the manager execute bulk write method. The first argument is going to be the database name, followed by the collection name, it's products, and then the bulk. This step is not required. Similarly, this one is not. So we have a manager. On that, we have called the execute bulk write. We have used the bulk write class, which is under MongoDB driver. And then we have called 4 operations on that bulk: insert, and then update, and finally delete on that. So let me run this one. Refresh, products, view documents. NetBeans ID is changed, updated successfully. Visual Studio is inserted. Yes, it's done. Price is 0. PHP Storm IDE, yes, inserted with price 19, and then drone parrot is gone. So this is how bulk write works. This is very simple but very useful for batch operations. GridFS with PHP, this is an important and useful topic, but currently there is a minor issue with the installation and configuration process for the MongoDB library. That is, under Composer's MongoDB SRC directory, you may not find the GridFS directory. This is in most cases. So you may need to pull the source from the GitHub, and then you need to manually replace this SRC folder's content with the GitHub's one. For instance, the issue faced, it will be like this. If you search for MongoDB GitHub PHP and then navigate to the PHP library page and to the API. Under this API, you can see we have a namespace GridFS. So there must be a corresponding directory under your Composer's MongoDB SRC location that is available under this C users, username, vendor, MongoDB SRC directory. If it is not available, you just need to download that from the GitHub source directory. That is this one. You just need to download the zip file and unzip the source contents under this. So you'll be getting the GridFS source code here. After this only, you'll be able to work with GridFS and MongoDB. Let me create a new PHP file for that. Demo grid. I'm going to use the code portions from our existing samples. We got the manager. In the API, we have a class bucket under this GridFS namespace, which has key functions for finding files in GridFS collection and uploading a file as well as downloading a file from GridFS collection. We are going to use that class bucket. It takes two parameters in the constructor. One is the manager, the another one is the database name. After this, we are going to use the upload from stream function, which is going to take file name as a parameter and a resource as a second parameter. So the bucket class here, new bucket. The first one is a manager parameter. Second one is a database name. I'm going to use the demo PHP DB for this. That's done. Next is a file resource. Let me use a local file which I have already saved. langs.jpeg. Yes. The mode. That's done. The final step is to use the stream method, upload from stream, upload from stream. The first parameter is file name. Let me give a random name, demo grid, and the resource, that's $resource. That's it. This is going to create a new collection and insert this file into that. We don't need these two. Manager, yes. Let me run the code now. Done. Refresh here. Yes, we got the new collections, view documents. Demo grid is there. Click view file. F1 view. Yes. This is the file which got successfully uploaded through our code. It's just a 3-step procedure. You need to get the manager, then you need to create a bucket class with this manager and the database as a parameter, then create a file resource, pause the file resource here, and close the file resource after this. This is how GridFS works with PHP, and always do remember to replace this src folder with the content from GitHub. In MongoDB, we have a run command method. In PHP, we have execute command, which we have used for our list databases sample. We have seen the available databases using the execute command against the admin database. To learn more about commands, just Google for MongoDB commands. It will list you the various command options. As I mentioned earlier, this is similar to the run command method, which is available under MongoDB. So this example we have seen previously for listing the databases available under admin database. So let me use the same for a different purpose, I mean a different set of command. It's going to be demo command. For example, if you want to get details about the database, you can always use the dbstats method and the database you need, php demo db. I want to get the stats of this particular PHP demo DB. This command DB stats, if you search in the command list, you'll be able to find that. This gives you the report storage utilization statistics. We are going to run against this PHP demo DB. This is the result of this dbstats command, which is going to give you the storage size. So in future, if you want to execute a command, just refer to the MongoDB database commands document, get the related command, and then use the command class and the execute method to execute against the preferred database. Node.js, MongoDB, this is a natural combination, as you know that JavaScript plays a very key role in MongoDB. The following are the key ones in Node.js MongoDB learning. The first step is to install the MongoDB driver using npm. The second and third steps, they inform about the IDE. Either you can use Cloud9 or Cloud Anywhere. These are all web-based IDEs, or you can go for desktop-based IDEs such as WebStorm, Coding, Komodo Edit, Atom, or Sublime or Brackets text editors. I basically prefer Code Anywhere and WebStorm IDE for my projects. So for this demo also, I'll be using the WebStorm IDE. These are the key classes we'll be using. The primary one is Mongo client, and the other ones are collection, cursor, admin, or the other key classes. We'll be using GridFS bucket for GridFS. So these are the basic points. This is our demonstration list. We'll be seeing the demonstration for a listing database, collection contents, creating new collection, inserts, finds, limits, sorts, projections, aggregations, update, drop, delete. And finally, we'll be seeing about the key one, that is bulk write, run command, and GridFS. So as I mentioned earlier, I'll be using WebStorm IDE for this process. And installation is very, very simple. You just need to do this one using npm for installing the MongoDB driver. I'm in WebStorm IDE. The first step is to create a new project for our demonstration. This is going to be of Node.js, Express app type, Node.js, MongoDB. Now we got the project. The next step is to see our demonstration list. So we're going to start with listing the databases available. So let me create a new directory, demo. Under this, I'm going to create a new JavaScript file or list db and collections. So step one is to import the required library. So for that, we are going to do this step, where MongoDB equal to require it's going to be MongoDB. That's the first step. Second step is to have the Mongo client. So where Mongo client is equal to MongoDB client. So that's done. Now the third step is to have the connection. We know that the URL is going to be the localhost URL to the DB. So the URL is MongoDB localhost. Default port is 27017. sorry, 17. The database we are going to connect is DB demo. So DB demo. So this is a URL we are going to use now. Now using Mongo client, we are going to do the connection. So Mongo client dot, it's going to be the connect method. We are going to give the URL and the function, it's going to be URL and the DB. So mapping. So under this, I'm going to list the database. So prior to listing the database, I need to shift the database, that is to the admin database, which is available under db.admin. So this will get us the admin database. The next one is to list all the databases available under this admin database. So dot list databases. It's going to be a function again. It's going to give an error, all the DBs. So we got the databases here. The next step is to loop through that to get the database listing. So where I equal to 0, let me use a traditional for loop. For I equal to 0, I less than DBs dot databases dot length I plus plus. I'm going to do a console log. Code reformat. So what we have done is we used the driver library, then we have created a Mongo client from that, then we have passed the URL to the connect method, and then we have connected to the admin DB. So on running this, we must get the list of available databases. In case if you're getting an error over here, the module is not listed, then you need to go to this settings, go for Node.js npm. If you search for npm or Node.js, it automatically pops up here. And on this, to install a module, just click install. It may take some time to build up the available packages. So on that, just go for MongoDB. The description, it will be mentioned as official MongoDB driver for Node.js. And then click install package. So our first demonstration is successful. We are able to list the databases available. Let me recollect the steps what we did. We used the MongoDB library, then we have created Mongo client class, and on that we have called the connect method with the URL. Then this is the important step that I used admin DB, and then on that I have called list databases, which is going to list me the databases, and I have printed the available databases here. Now to the next one in our list, that is to list collection contents. So let me create a new JavaScript file, list collection contents. So the steps are same. Let me copy this code. We are not going to use this one. Till this, it's a common code part. I'm not going to use the DB demo. I'm going to use a different database this time. That is demo PHP DB. Under that, we have a collection by name products. Demo PHP DB. The collection name is products. Once we got the connection, we are going to get the database DB dot. It's going to be list collections. We are going to turn that into an array of function, which is going to be the function. It's going to be error and the items. On looping through these items, we must get the names of the collections. So the steps are same. Equal to 0. Less than items dot length plus plus. It's going to be console.log. We go to items array. Under that, we are going to get the name. So DB collections to array, and then we have did this. This closes here, this closes here. And finally, we are going to close the DB. We are using the list collections method. That's very easy. So these are the collections available under that we have already seen. One more thing is always refer the API if you are not confident about the method to call. Click on the API. We are under DB. Here we have the method list. We have used the list collections. The samples are given here. Now to the third one in our demonstration, that is to create a new collection, and we'll create a new database. That's very, very easy. So for this, I'll be taking some code portions from our previous examples. Let me copy this one here, and we don't need this. Our target is to create a database and a new collection under that. So let me name this one as db.node.js demo. This will be our new database. This is currently non-existent, and this will be created once this is done. Next step is to call the create collection. So to know more about this create collection method, as I said earlier, refer to the API. So under DB, methods are listed here. And I'll be able to see create collection under this. Yes, this is the one. It's very simple. The next step is to give the collection name. I'm going to give this as products. On running this, we must see a new DB created, and with the collection named products under that. It's done, I hope. Yes, we got a new DB and a new collection. This is how create collection and create DB works. It's very easy. The next one in our demonstration list is insert. So we'll see both insert single and insert many, and then we'll see about find queries. It's going to be insert demo. For insert demo, we'll be using some code blocks from our previous example. And then this portion for connecting. We have two types of inserts. One is insert one, and the second one is insert many. For insert one, it's simple. We are going to just provide a single document. In our case, this one is a db.collection. The collection name is products. And that we are going to insert one. It's going to be the name of the product, that is Amazon Echo, the price of that, it's going to be 180, and the category is electronics. So once we have done this, we must be able to see that this document got inserted into the products collection. So let me do a console.log. Insert succeeded. So on running this, it must create this record, this document in our collection products. So let me run this one. The insert is successful. As you can see, we got one document in our collection. So for insert many, it's the same. So we need an array bracket for this, since we are going to have multiple documents. Come on, third one. Here, this one is Amazon Fire TV, and this is paper white. That's around $100. This is also around $100. On running this, we must see multiple documents inserted into our products collection. So let me do that now again. To MongoBooster. We got multiple inserts using insert many. So this is a way to insert a single document and to insert multiple documents. Now to the next one in our demo list, that is find and find with query. This is very, very simple. Find is very, very simple. Let us use the same code block from our previous demo for insert. So instead of insert and insert many, we are just going to use the find method. So find, and then we are just going to do a to array. So to array will give us a function. Under that error, docs will be there. This will be because of this find method we got. And once that is done, then we just need to print the docs. Let me do a console.log of docs. And then do a db close. So this is the matching for that. So it's simple. We just got a find method without any filtering parameters, and we are converting the result to an array, which is going to give us the docs. And if you want to print the error, you can easily print by using if statement. And the else block, you can print this portion. So it's very, very simple. We just need to call the find method. Let us run and check the results. So we got Amazon Echo, Amazon Fire TV, all those. So this is how find works. We got 3 results, right? So to limit that, you can always use limit function. You can limit by 1. And running this, we will be getting only 1 result. So limit is seen. Next is sort. So let us sort by the price. So under sort, we are going to give the field name. The field name is going to be price, and the order is going to be -1. So the most priced will be listed in the top. So this will give us a top 2. So 180 is the most priced, so which got listed here, because we are doing a descending order. So this is how sort works. In case if you want to filter the results, you can give the filter over here. For instance, in my case, I'm going to filter by price, which is equal to 180. Let me take out this one. So these are the 2 records with price 180. So this is how it got filtered. And in case if you need only few fields in the output, you can use the projection criteria. That's very easy. So in my case, I don't want the ID, so I'll be making ID as 0, and I just want the name. Name is 1 and price is 1. Means the columns name and price will be included, whereas ID will be excluded. Sorry for terming it as column, it is field. So fields will be included and this field will be excluded. So let's see the result. So we got it clearly here. So this is how you can do projection. So we have seen about projection, sorting, limiting. So in our list we have covered limit, sorts, filters we have did, and projections. So these 4 are covered. Find with query is also covered. Aggregation, let us see it later. Now let us go to update one, update many, delete one, delete many, drop collection, drop database. These are easy ones. Next one is a demo. Update and delete. I'm going to take the same sample from here. The next one in our list is bulk write. As you know that bulk write is used for batch operations. So in turn it reduces the number of round trips to the server. The bulk write API is a little bit different. So let's start with that. I'm going to create a separate JavaScript file for bulk write demo. And as usual, I'm going to use some portions from our existing code. So we don't need this one. So now we got the connection to the database. Next step, as usual, we need to get the collection. We're going to use the product collection. So db.collection. The name of the collection is products. On collection, we are going to do a bulk write. Let me call the bulk write function. The next step is bulk write. We are going to do many updates and inserts in a single operation. So array is required. Then let's start with insert one. Watch this API or the syntax because it's a bit different and compared to the insert one. In insert one, in a previous case, you might have seen we might have called the method here, whereas in this case, the API call is different. Let me save some QNest security camera. Price is around $50 and a category is electronics. So this is our first record. The second one is going to be a update. I'm going to update this 199 as 190. So price 199 is the one. Filter is finished. So next is the update. Come on, update. So for update, we'll have a set operator. And for that set, we are going to set the price value. Price 199, I'm going to make it as 190. Matching, it's matching. So for update one, the loop is ending here. Filter. So everything is fine. Now let us collect the result. Function, it's a error result. So console.log, it's going to be done, and db.close. So we are doing only two operations here, insert one and update one. Just watch the syntax. It's a little bit complex when compared to the other ones, but it will be very, very useful. Make sure that you finish the loops properly. Let's run this one, bulk write demo. So it's done. Let's check the database. We must see new insert. Yes, we got the new insert. And similarly, this value is also got updated. This is how bulk write works. Here we have used only 2 operations, but there are many other operations. As you know, we have delete one, delete many, update one, update many. That can be also used here. This is how bulk write works. Just make sure that you have a square brace here and all the brackets must be correctly finished here. Now let us move to the next one, that is run command. Run command is very simple and easy. So we are going to use the file IO here. First up is to use that. So where fs is equal to recover fs. So that's done. Second step is where grid is equal to recover. The other steps are similar to the previous ones. So let me take some code part from here. So now to the file uploading part, file saving part in GridFS. GFS is equal to grid. So in this we are going to give the database, that is a DB and the MongoDB. The next step is to read the local file. From file will be using for this. This API is very simple that it will reduce the complexity. File name is Langs demo. The source of the file. Let me have a separate variable here for that. So to add clarity, file source is equal to, in my local machine I have a file in temp folder. The file name is langs.jpeg. So I'm going to give the same here. That will be src. That's it, done. Next we'll have a function which will have error as the first argument and the file data, console.log, make it as file saved successfully. Followed by this, I'm going to close the database. You can add a step here if error return or something. So we are here to just understand what this one does. We used grid here and passed DB and MongoDB as parameter. Following that, we have used the from file function where we'll be giving a file name in which it's going to be saved in the database, followed by the real file name which is in the local machine. So let me run this one. File saved successfully. Refresh here. We got the new collection, view documents on that. We got the Langs demo, which we have mentioned here, Langs demo. And on double clicking, we must see the file. So this is a file I have uploaded from my local machine here. Similarly, you can do actions for reading. It's clearly given in the sample over here. So I just used this one. You can use read file, write file, to file, all those. So just try to use this npm package which eases your work for GridFS and Node.js. It's very simple. With this, we have seen about GridFS. So we have covered all the topics except aggregation. Let us see about aggregation. Aggregation is very easy. The next one in our list is aggregation. Aggregation is of three types, as you know: single purpose aggregation, aggregation pipeline, and MapReduce function. We'll be using single purpose aggregation and aggregation pipeline for this demo. To start with, I'm going to create a separate class for this one. Separate file. Aggregation demo. So I'll be using some code portions from our existing examples. Now we are connected to DB Node.js demo, to this products collection. This is the data in a products collection. This is very simple. Let us do the count first of the number of records in this collection. So for that, you just need to call the collection, the name of the collection here, and then the count. So we are not going to filter anything. We want the count of all the documents. On running this, we must get the total count of documents in that collection. So it's 13. It's matching. Now let us see the distinct values here. I'm going to take a distinct on this particular name. So that's very easy. Distinct. Here, let me select the field name, its name here. So these are the distinct names available here. So this is how single purpose aggregation works. Now let us see the aggregation pipeline. That's also very easy. As you know, we have match in that, we have project, and we have the important one, that's group. So let me use the same for this. I'm going to comment out this portion. We'll be calling the aggregate method. Collection, the name is products dot aggregate. This is the one we are going to use. So to start with, let us use match first. So in the aggregate, I'm going to use a match operator. So for match, I'm going to list the items with price greater than 100. That's simple, price. And then we'll be using the greater than 100. That's it. So on running this, we must see the documents with price greater than 100. Code format, yes. So we got the list of documents with price greater than 100. So that's our match operators work. Next, I'm going to project only name and the price. So for that, I'm going to use the project operator. That's very easy. Project. Oops. Name is yes. Come on. Price is yes. Come on. The ID column we are going to ignore. So this is how project works. We got name and price. ID and category has been filtered out. The next one is the important one. We are going to use a group operator. This is a bit challenging when compared to the other ones, because here every field will become a variable, as you might have worked with a group already. The first one is the ID column. ID, it's going to be the name field. I'm going to find the total price under each names. For instance, you can see here a duplicate document is there with the same name, Amazon Echo, price is 189. We must get the sum of this one. So the next is sum operator. And we are going to do the sum of price. It's matching here. Yeah, this is wrong. So let's run this one. So we got the result as expected. We got 2 instances of Amazon Echo with price 189 each. Now using sum, we have summed the total price. This is how aggregation works. Let us recollect what we have done. We have seen about single purpose aggregation initially. We used count and distinct. Later we have used the aggregation pipeline. We used aggregate. We use the match operator, project operator to filter out the fields, and the group operator. So with this, we have seen the complete Node.js demonstration list. We are going to see how to use Python with MongoDB. It's very simple. MongoDB team has given a clear set of examples to do the same. So on Googling for PyMongo, you'll be able to see this link, PyMongo MongoDB API. Click on that. So this is a documentation page for PyMongo. As I said earlier, clear examples are given over here by the MongoDB team. And similarly, the installation steps are all explained over here. I'm going to demonstrate how Python works with MongoDB using 3 simple examples. The first one is a CRUD demo. The second one is bulk operations. And the third one is the important one, that is GridFS demo. So let's start with the basic one, that is CRUD demo.py. I'm using the PyCharm IDE over here. Let me walk through the code. The first step is to import Mongo client and version from PyMongo package, and then I have given a print for version. Then we are connecting the Mongo client to the local host. Following that, I'll be connecting to the database. In my case, the database is InventoryDB, and I'll be using this one, products best selling. So this is the collection I'll be using for demonstration. The first step, it's going to get the total number of documents. So like we do in the command line, here also we are going to do the same. So db.productsbestselling.find and then a count. So that is going to give you the total documents here. Let me do the same over here. On running this, we must see the count. So that's 15 here. That's in the command prompt of NoSQL Booster. And the second thing is we are going to filter the query based on this particular condition where name is Amazon Fire 7. So what I have did is db.productsbestselling. So this is a collection name, and then I have called the find method, and I'm passing the filter query as a parameter here. So let's do the same in the MongoBooster. I mean the NoSQL Booster. So no records are there currently. So let me give a query for Amazon Fire TV here. So Fire TV. So we got it. I'll be doing the same here. Then we have a filter to list out the products with price greater than 100. So let me copy the same query over here to NoSQL Booster, and on running I must be able to see the records here. So the same query is copied to the Python code also. That's the beauty of this. And then we have update query over here. Instead of Fire 7, I'm going to change this Fire TV. So to cross check it, I'm just going to copy the same code over here and execute in NoSQL Booster. On running this, yes, it has been updated. Following this, we have insert and then finally delete. So this is the main thing you need to remember in Python using MongoDB, is that you can simply copy the queries from your command line directly to the Python code. Now, the only thing to note is that you may need to use the single quote or double quote for the key value. So that's the only thing. This code is available in the resources section. Please use that. So it's very, very simple to work with Python and MongoDB. You can simply copy the queries from your MongoDB command line directly to the Python code. Following this, we have bulk operation. Bulk operation is very simple. I have just imported insert1 from PyMongo library. Then I have called the bulk write method over here. Following that, individually I have called the insert1. So this will be inserting records into the MongoDB as a bulk operation. That's the thing. It's very easy. To know more about bulk operation, you can just search for MongoDB bulk operation. So this is the method, that is bulk write, which is used in MongoDB command line. In Python also we do similar operation. As you can see here in this example, it's given very clearly. We have insert one, update many, replace one, delete one, and delete many. These all operations will be done in a single step. So that's called bulk write. So the same thing I have did here. I just called insert one, and then I'm just inserting the documents over here. So the next one is GridFS demo. It's very, very, very simple. As you know that GridFS is used when you are going to store and retrieve documents or files which are greater than 16 MB allowed size. So if your file size is going to be greater than 16 MB, you have to use GridFS. We are going to see how to use GridFS in Python. It's very simple and straightforward. I have just imported GridFS. Following this, I have called GridFS over here. So for saving the file to MongoDB, I am using fs.put method. I have put two different files. One is a PDF and another one is an image file. And similarly, to retrieve them, I have used find one method, and then I have read the file content over here. So let me run this one. Yes. So two are saved, and similarly this one is retrieved. Let me cross check the same. On refreshing, we must see GridFS. Yes, we got it. View. Yeah. So the files are saved here. On clicking this, I must be able to see the file content. So this is a file which is saved in the MongoDB server. We did that through our Python code. And this is the image file. Yes. The files are saved over here. And I have retrieved the files. Path out is here. So this is the file output created. It's the same. It's very simple and straightforward. You just need to import GridFS in the top. So after this, call the GridFS and then call the put method to save the file and read method to read the file. That's it. So it's very simple and straightforward. So this is how Python works with MongoDB. It's plain simple and straightforward. For more information, visit the documentation page of PyMongo, where there is a separate example section which gives you a good idea about how to work with Python and MongoDB. MongoDB in less than 50 minutes. So the target of this video section is to give you a good know-how of MongoDB in less than 50 minutes. So after this video, using the accompanying documents, you will be able to work out the key sections of MongoDB in ease. We'll be covering most of the commonly used key topics of MongoDB. In this video section, we are going to cover these topics. The first one is the basics, where we'll be learning about the basics of MongoDB. The second one, we'll be seeing about CRUD operations on MongoDB using MongoBooster client. We'll be seeing quite some queries in this example. Following this, we'll be learning about capped collection and TTL. These are very easy and important. Then we'll be learning about regex, full text search, and finally GridFS and aggregation. These are very easy and important. So our time starts now. So this is the PDF which is available in the resources section of this lecture. This has 11 steps. Each step has its own queries and examples. The step 1 is to learn why MongoDB is different and a simple overview about MongoDB. MongoDB is a NoSQL database. As you know, it's a leader. NoSQL primarily offers two features, that is the schemaless feature and the second one is horizontal scalability. So these are the two things you need to remember about a NoSQL database. So MongoDB is like a Word document which is completely structureless and you can put anything into anything. Whereas the traditional databases like Oracle, MySQL or like Excel sheet, where the data will be arranged in tabular format. So this is the primary difference between MongoDB and the traditional database. There are three key things you need to remember about MongoDB. That is, it stores data in document format. The data will be in JSON format. And finally, you need to learn about the methods available in MongoDB. That is very, very important. So this diagram shows the important components of MongoDB. We have a MongoDB server. Under that, you can have many databases. Under databases, we have collections. Collection is a group of documents. So this is simple. Server has databases. Database has collections. And collections will have documents. I have connected to my local instance of MongoDB using a RoboMongo client. And you can see how the data is organized in a collection. The document will be of JSON type and it will be saved in binary format that is called BSON. To know about JSON, please open the document which is in the resources section. Click on the sample JSON structure. This is a Wikipedia link. On clicking this, it shows a simple personal details JSON. As you can see, we have key value pairs, both are string. Then we have collection of key value pairs. So this is called object. Then we have age as a number, and then we have an array. Back to the document. To have a very quick reference about JSON, click on this link. This gives you a clear idea about a JSON data type. For instance, we have array here, we have Boolean, it supports null value, we have number values, and this is called an object in JSON. Then we have the regular string key value pairs. So this example can give you a good understanding about JSON data types. I'm in the reference documentation page of MongoDB. As you can see, the operations in MongoDB are done using methods. For instance, this find method is for finding the documents. Find and modify is for finding and modify the documents. So these methods you need to remember. Traditional databases uses SQL, whereas MongoDB uses these methods. So this is the primary thing. So always remember that MongoDB has methods. We have seen the step 1. The step 2 is to install MongoDB and its client MongoBooster. MongoBooster is one of the best client of MongoDB, primarily because it has two key features, that is IntelliSense, and it has code snippets support. So you can see the code snippets, as well as you will be getting IntelliSense for any kind of method. So to download MongoDB, just Google for MongoDB downloads. It takes you to the MongoDB download center. Click on this. I'll be using the Windows version. Click on the MSI file. It's a straightforward installation. Once MongoDB installation is done, you need to run the MongoD.exe. This is the server process under this path, that is C program files MongoDB server 3.2 or 3.4 bin. And then you just need to run this MongoD.exe process. You can run this by double clicking, or you can run through command line. Prior to this, there is a very key step that needs to be done. That is, you need to give a data directory to MongoDB. MongoDB generally expects the data DB in this path, that is C data DB. So create this folder and then start the server process. You can double click it, or you can run through the command line. So it's cd paste here, then MongoD.exe. So that's it. Once you are able to see this particular line waiting for connections on port 27017, this is the default port for MongoDB. It means that your server is started successfully. The next step is to install MongoBooster. That's very easy. Search for MongoBooster downloads. Click on the link. You'll be getting a fully functional version for 60 days. The installation is very straightforward. Download and install. Once installed, you just need to run the MongoBooster process just by clicking here. The connection is very easy. You just need to create a connection. The default values will be auto-populated. Press test connection. It will be successful. Once that is successful, just save and connect. Now I have successfully connected to the MongoDB server. As you can see here, I have many databases pre-created on MongoDB and they are getting listed. Under databases, I'll be having collections. So click on that, you'll be shown the collections. So these are the collections. For instance, in this collection, I have around 24 documents. So this gives me the documents. The data is presented in tabular format, but the true format is on JSON format. So this is the format in which the data will be presented to you, but MongoBooster is giving you options to view the data either in tree format or in tabular format or in the true JSON format. Now we are in step 3. Step 3 is to create database, create collection. Just remember the architecture: server has databases and database has collections. Let me create the database first. Right click, create database. The database name is demo. So database is successfully created without collections. Now to create collection, right click, create collection. So let me give the name here. I think it is user profile. Yes. So user profile. Okay. Collection is successfully created but without documents. Open shell. Let me create collection through command line now. Pasted the code. Let me make it as a user profile. Yes. On executing this, you can see the collection is created through command line also. Refresh. So we got two collections: user profile, which is created through wizard. The second one is user profile X. I'm going to drop this one, drop collection. On running this, the collection got dropped. You can see true printed here. The next step is to insert documents into this collection. For this, we'll be moving to step 4. There are two key things to note are document with different structures in same collection. Every document will have a default underscore ID. So let's see the first one. For instance, here we'll be having two user profiles, one with ID, name, age, income, sex, nationality, language, additional info, etc. The second user profile will be different, where we'll be having user ID, logged in, last login, location type, etc. So different structures. This is a sample data which we are going to insert. This is the first one and this is the second one. So two different types of documents are going to be there in the collection. So that's important. Step 5 is to do a basic CRUD operation in MongoDB, insertion and multiple insert in single query. Sample data. So we are going to insert the first sample data. Let me select from the JS file which I have. Now I have to paste this on the window. Right click here, view. So it's an empty collection as we know that. I'm going to paste here. Pasted. As you can see here, we are going to insert in user profile. The query is very clear. If you keep the cursor over there, you'll be able to see the method, syntax, everything. Now let me show you the code snippet, user profile dot insert. As you can see here, you can see the code snippet as well as the method definition. The code snippet is easy, you can easily understand from it, and the method definition is below that. So that's the coolest feature of MongoBooster. Now I'm going to run this one. On running, we must see two documents created. Yes, two got created. Right click, view. So these are the two documents created in JSON view. Now back to table view. Now I'm going to insert the sample data too. So let me copy from the JS file. Copied. I've pasted it. And I'm going to execute this one. On running this, new documents are created. So totally we have 5 documents. Right click, view documents. So we have 5 documents. As you can see here, the documents have completely different structure. That's the beauty of MongoDB. We can have different structure documents in the same collection. So this is what is the first point we mentioned, documents with different structures in the same collection.
The second one is every document will have a default field ID. So this field underscore ID is created by default. It is auto-generated. It is unique. There is a bug with MongoBooster that this ID column, which I haven't mentioned, is shown there. But if you check with RoboMongo software, there is no ID column. So it's a bug with MongoBooster. So ignore that. So just focus on this one. This ID column, underscore ID column, is auto-generated. So it's auto-generated, unique, it is indexed and can be replaced. So now to the step 5b, that is CRUD operation in MongoDB, finding documents. I have the code here. Let me copy paste to MongoBooster. Right click, view documents. I'm going to paste it in a new window. So pasted. The first one is a find method. So under collection methods documentation, you'll be able to see the find method. db.collection.find, and we have the query and the projection as a parameter to the find method. So let's do that. Field value. So I'm just giving a empty find. So it is going to list all the elements. So we got it. The next one is nationality. We are going to select as Australia. Let me execute this one. So we must see the record only with Australia. Yes, the single record with nationality is Australia is listed here. The next one, we are going to use the age field. For instance, here age is greater than 30. To know about these operators, please visit query and projection operators section in the documentation. Click query selectors. You'll be able to see the operators equal to, greater than, equal to, less than, equal to, not equal to, and all. So we are going to use greater than operator here, and the next one will be using less than operator. Let me run this one. So we got age greater than 30 listed here. The next one is to find documents with age less than 30. So we got a single document with age less than 30. Here it is 26. The next one is the AND operator. We have two conditions. The primary key to note is the square brace. So we'll be having multiple conditions within the square brace. The condition number 1 is the age has to be less than 35, and the condition number 2 is age has to be greater than 20. To know more about AND and OR operator, visit the query and projection operator sections in the documentation. Under this we have logical operator. Yes, we have here. You can get the details of AND, OR and other logical operators here. Now back to our code. On running this, we must see documents with age between 20 to 35. Yes, we have two documents with age between 20 to 35. Next, it's the same for OR operator, which is going to give us a lot of documents because the conditions are same. It is similar to AND operator, but in the opposite way. On executing this, so these are the documents with OR condition satisfied here. The next in our list is count, limit the number of documents, which is going to skip the number of documents, and sort. We have 1 for ascending and -1 for descending. So we are going to see this. The first one is count. On running this, it's going to give the count of documents. Yes, we got 6. The next one, we are going to limit the number of documents to 2. So we must get only 2 documents. Yes, we got only 2. Following this, we have skip operator, which is going to skip the top 2. So we'll get 4. The other 2 documents are skipped. The next one is sort method. We are going to use the ID field, which is going to do a -1, that is descending order of this ID field. Let me execute this one. Run. Yes, we got the ID field in the descending order 4, 3, 2, 1. So if you want to see the definition of sort, you just keep the cursor over there. You'll be able to see the description of it. We have seen finding documents. The next is 5C, that is update and deleting documents. So we are going to use the update method. We are going to update the location US to location as the United States of America. To MongoBooster, right click, update documents. So we got the query here, update. You can see the update syntax here. Then we have a set operator. Then we have option fields multi. Multi means it will update multiple documents. Currently it is false. These are all option fields. The next we have upsert. Upsert means it will find for the document. If it is not there, it is going to insert. It is also set to false. So this is optional. We can totally take it off. So let me take the query from the JS file. I have copied it. I'm going to paste here. Yes, done. On executing this, we must see a single document updated with location US to USA. Done. So one matched, one document got updated. Let me view the documents to see the changes. View. Yes, as you can see here, one document has got updated. That is because we have set multi as false. The default is multi false. It's not like our traditional databases. So if you give multi as true, the option as true, it is going to update multiple documents. So let me execute this. On running this, the documents got updated. Let us view the documents. Right click, view documents. As you can see here, the documents have updated. The next one in our list is to do a remove. Let me copy this code here to MongoBooster. On executing this, the first two documents with user ID 01, 001, 002 will get deleted, so removed successfully. Right click, view documents, so the documents are gone. So this is how remove works. It's very simple. You just need to call the remove method. So we have finished updating and deleting documents. So we have finished the basics. We have finished the simple CRUD operation. The next is capped collection. Capped collection is very easy. The only main difference between capped collection and the other collections are we have a size limitation in capped collection. For instance, we'll be setting the maximum size as 10 here. So it can hold only 10 documents at a time. So all other documents will be ejected out. So let me copy this query. Paste it here, done. Capped is true, size is limited, 50 KB. On executing this, we must see a new collection by name, log capped. Let me do a refresh. So we got the log capped collection without any records. Now I'm going to insert the test data into that. Now I'm going to insert the demo data into log capped collection. Let me copy from the JS file. Now I'm going to insert log data into this. As you can see here, we have log 1, log 2, log 3, log 12. So this is the demo data we are going to use, but the max is 10. So 2 of this will get ejected. I mean the log 1 and log 2 will get ejected. So we must have only the data from log 3 till log 12. Run, success. Let me do a refresh first. Yeah, we got only 10 records as you can see here. That's because we have capped the collection to 10. Let me view it. Yeah. So as I mentioned earlier, we have only 10 records, that's starting from 3. We're going to see about indexing. Indexing is one of the primary part of database management because it fastens your search query. In MongoDB, by default, it creates an index on every document on the ID field. So in this demo section, we are going to learn how search works before and after indexing. So for that, we'll be using explain method. So this is the field I have been mentioning. Default index is created in the ID field.
Let me copy the query. As you can see, I'm searching for income with around 6 million. On executing this, we'll be able to see the result in JSON format, where we'll be getting the total number of documents examined. That's here. Currently, we have 4 documents, and all the 4 documents are examined to find a document with this income matching. So let us create an index on the income field and see how the search works out. So we are going to create an index on the income field. The syntax is very easy. That's create index method is called with the field. On running this, yes, the index has been successfully created. Number of indexes after is 2 and before is 1. And you can use view indexes to see the indexes in the collection. Get indexes. Now you can see here we have 2 indexes. So now let us see the execution statistics. On clicking run, we must see the documents examined must be less. So total docs examined is just 1. Previously it was 4. So that's the power of index. To drop index, it is very easy. You just need to call the drop index method on the particular field. That will drop the index. Now to the step 8, that is a TTL collection. TTL collection stands for time to live collection, where the data will be kept only for the specified seconds. Note that it is seconds, not milliseconds. So the documents will be automatically deleted after a particular specified second. So in our case, demo TTL is a collection name. To create a TTL index, it is very easy. You just need to create an index specifying that it will expire after particular second. So log data is a field, demo TTL is a collection name. So create collection is demo TTL. Now it's created successfully. Right click, indexes, add index. So add field. Field name is log underscore data. Okay. Expire after. Just see the field. We have expire after. I'm specifying. I'm going to preview it. On clicking preview, you'll be able to see the query here. So it has created so create index on this field, which is going to expire after seconds 10. So it is similar to our query. On running this, we must see expire seconds. I have to select completely. On running this, we must see the index is created successfully. So the number of indexes after is 2 and before is 1. Now right click, indexes, view indexes. So as you can see here, we have 2 indexes now. The expire after seconds is 10 for a particular index. The next step is to insert the test data. Now we don't have any data here. As you can see here, I'm going to just insert date on the log field. Let me copy this. So log data will have only date. I'm going to run this multiple times. 1, 2, 3, 4. So 4 times it got executed. You must see 4 documents here. View. So we got 4 documents inserted at different times. As you can see here, I'll keep on executing this. So after 10 seconds, the data must go off. Yes. Now there are no records in the collection. So this is how TTL index works. So just remember the syntax. Now to the next step, that is step 9, text search. Full text search. Full text search is very important in MongoDB because it is schemaless. It's very easy to do a full text search. You just need to create a text index on a field. As you can see in the documentation here. So this is a documentation page for text search. MongoDB supports query operations that perform text search on string content. MongoDB uses text index and the text operator. So this is important. So we have to create a text index and we have to use a text operator. So this is the syntax for the text operator, which will be performing the search. We'll be giving the search string first, then we'll be specifying the language,
Then we'll be specifying whether it's case sensitive or not. And finally, we'll be specifying whether it is diacritic sensitive or not. So this is the syntax for text operator. Prior to that, do remember that we need to create the text index. So let me do the first step, that is to create a text index. Let me copy from the JS file, copied it. So demos text search is the collection name, copied it, pasted here. So we don't have an index. So let me create a collection for this. So demo text search. So the collection is created. Now I'm going to create an index on the message field. So indexes before and after is 2 and 1. Indexes, I'm going to view indexes. As you can see, we have 2 indexes. One is of type text. Now I'm going to insert text data value into full text search. So let me copy it from the JS file, paste it on MongoBooster, and then run it. So now we must see around 11 records here. Let me do a refresh. We have 11 records. 11 documents. If you see the document, it's very easy. It has messages, good coffee with cures fatty liver, good coffee, best Mongol. So it's a simple document. Search in full text. The first one is to search for message with good, easy. So it will be search both with good and easy. Let me paste it. On running this query, we must get messages with both good and easy. But currently we won't find because it's not a text search. It's a plain find query. So it won't find anything. So let us give it same thing with text search now. Pasted it. As you can see, I have used the text operator. Previously I haven't used it. And then I have given the search operator. On running this, we must see the documents with both good and easy. Let me expand this one. So easy. So we have documents matching easy and good. Now I'm going to ignore fatty. On executing this, we must get results without fatty. Yes. So the document with fatty text is not selected. So let me show it again. In our previous execution, we got the document with fatty liver is mentioned, but currently, since we are ignoring it, the particular document with fatty text is ignored. Next one, I'm going to search a complete text is also here. On executing this, we must get an exact document. So which has the exact text. Now the interesting one, that is, I'm going to search for goodness. It will be listing the documents with good also. That's the power of text search. Selected, run. So you can see documents with good text also. So that is the intelligence of full text search. Now to the next one, where we are going to search for easiness. So it will list the document with words easy also. Let me run this one. As you can see, MongoDB queries are easy. So this document got listed after we searched for easiness. Similarly, we can search for happy. We will get documents with happy as well as happiness. As you can see in the result, we have document with happy as well as happiness. Now I'm going to search the word the easy. The word the will be ignored. Let me search it. As you can see, there are no the in the document and it is ignored. So the common words will be ignored. The next one is very interesting and important. Please note that every document search will have a text score. You can also manually rate a document, or by default it will be given a text score. Remember that every document has a text score. So now we are going to see what the text score for every document. I am going to search for coffee. So as you can see here, the search results have score mentioned over here. So every document is having a text score, and note that the text score is based on its own algorithm. For example, if you take the first document, we have coffee repeated many times, so its text score is higher for this particular keyword coffee. So it's easily understandable. This is how text search works. So 3 things to remember. For text search, you must create a text index. Number 2, you need to use text operator and search operator. And number 3 is every document will be given a text score by default. You can also edit the text score manually. Now let us move to the next topic. We are going to see about regex. Regex is very important because we have different formats of data, and regex eases our work. This is the documentation page for regex, and we'll be using the regex operator. The good thing about regex is that it is Perl compatible. PCRE or Perl compatible regex are very famous. The syntax to use regex operator is shown below. As you can see here in the leftmost, we have a field name, then we have a regex operator followed by pattern, and then we have options operator with different options. This is a sample data we are going to use for our demo session. It is very simple and it has only name field. Now let me copy the data to MongoBooster. Pasted. On executing, we must get around 13 records. Refresh. Yes, we have the persons collection with 13 documents. So we have Rick David, Elizabeth David, David is in uppercase, and David Warner, David, John David 1, Paula David, Davidson, David King, first David, fifth David, Siju David, and then the names Arun, Karun, Ahmed without David in them. Now let us start with the regex queries. So now let us start with the first one in regex queries. Let me copy this to the MongoBooster. On executing this, we must see names with both David and Arun in them. So we have Rick David, Davidson, David, all those. And then for Arun, we have Arun and Karun. Karun is included because Arun is there. Now to the next one. Regex search with all David in caps and with options as I. If you see the documentation, I is for case insensitivity. So we have case insensitive search here. So let me copy this one and execute here. And on executing, we must see David names with David in both small as well as in capital letters. So that's done. The next pattern is similar to that of the first one, which has the same function as that of the first query what we executed. And similarly, the next one is for ignoring the case. Let me execute this. The result will be similar to the first one. So we got the similar result to that of first one. And for case ignore search, so we have both cases listed here. Now this is a simple query where we are just going to search for David in caps. So let me execute this. On executing this, we must see only 2 documents with David in caps.
Now this is interesting. We'll be searching for starting with. So here we are going to search for starts with 1. So we must get first David. Yes, we got the same result as we expected. Result is first David. The next one is we are going to search for the term son star. So we'll be getting Davidson here and case is ignored. As you can see here, we have Davidson, David King. This record will be listed in the result. Running this, yes, as we expected, we got Davidson, David King. So that's because of this pattern. To the next one, where the name is going to end with run, we'll be using the dollar symbol in that selection, and then on executing, we must see Arun and Karun. Yes, as we expected, we got 2 records with ending with run dollar. Next is we are going to search names with digits in them. Let me select this. On execution, we must see 3 documents. Yes, John David 1, where we have number, first David, and then fifth David. So this is how regex works. With this, we have seen about the basics of regex operations in MongoDB. You need to refer to the Perl regex manual and MongoDB regex manual. GridFS is very important, as you know that it allows us to save as documents with sizes more than 16 MB, which is the BSON limit. This is the GridFS documentation page. GridFS is a specification for storing and retrieving files that exceed the BSON document size limit of 16 MB. So this is the definition for GridFS. Instead of storing a file in a single document, GridFS divides into parts and chunks and stores each chunk as a separate document. GridFS uses 2 collections to store files. One collection stores in file chunks and others in file metadata. So this picture can give you a good idea about GridFS. As I said earlier, always remember that there is a 16 MB file limit for the BSON file. So using MongoDB, we'll be using MongoFiles command. We'll be creating a bucket which will have 2 collections for FS chunks, which will save file chunks, and a FS files collection which saves the metadata about the file chunks created above. So this is very easy. Let us see a simple demo. We'll be using a simple demo using MongoBooster. We'll be using GridFS bucket and it will create 2 collections, FS chunks and FS files. So first step is to right click here, create GridFS bucket. On clicking this, demo underscore GridFS. So the name of the bucket is demo underscore GridFS bucket. And on clicking OK, we must see a new bucket here with the symbol of save icon. The next step is to add files to that. Right click, add files. So this is the image file I have selected. There are 2 options, with full path, without full path. I'll be selecting without full path. On clicking this, the file will get uploaded and the file got saved in the bucket. And on right clicking, on clicking view documents, we must see file chunks, around 6 we have. To view the image, double click here. It shows the image uploaded. Note that this is in MongoBooster, not in image viewer. Now we have seen a simple demo about GridFS. Now let us move to the next topic, that is aggregation. This is one of the important topic in MongoDB, but it is very easy to understand. In aggregation, we have 3 types of aggregation. Aggregation pipeline. This is a widely used, commonly used one. The next one is MapReduce. Aggregation pipeline replaces MapReduce. And then we have single purpose aggregation operations. Under single purpose aggregation operations, we have count, distinct and group methods. Count is for counting, distinct is for getting distinct records. Group is not suggested to use. So let us see more about aggregation pipeline.
For aggregation pipeline, we have stages, expressions, and accumulators. As you can understand from the name itself, stages process the data in stages. So match operator and group operator are used. Whereas for expressions, we have string arithmetic expressions, and for accumulators, we have sum, average. To easily understand about MongoDB aggregation, Google for MongoDB aggregation, click on the link aggregation under MongoDB manual, click aggregation pipeline. A very good diagram explaining aggregation is provided. As you can see here, we have different order details. So we have aggregate method, and we have two stages here, that is a match stage and the group stage. We have different order details here, each one having a custom ID. A match operator is applied, and customers with status A are matched here. All are having status A. The last one is having status G, that is ignored. Then a group operator is applied here. The group operator groups the records with similar customer ID, and it shows the total of the orders in status A. This clearly explains how aggregate works. So let us start with the user profile count. We are going to do a count in the user profile collection. So we have 4 records here, view documents. Now we have 4. Count has to give us 4. We got 4. Now db.userprofile.distinct. I'm going to take off this slice, it's not required. Distinct on a particular field name. So let me do a find to see the field name. We're going to do a distinct in the age field. So here it's age. On running this, we must see the distinct age values. So this gives us a distinct age values. So we have 35, 26, 30. So those are distinct. Now to the third query, where we are going to use the aggregate method. We are going to match based on the income greater than 4 million. Code from here. Let me copy the query from here. Paste it on MongoBooster. On running this, we must see records with income greater than 400,000. So we got 5 and 7. So both have greater than $4 million income. Now to the next one, where we are going to use group operator. We are going to count the total users using the sum. On running this, so we must get 4. We got 4 because our greater than value is 40,000 only. So we got 4 total users. Now to the next one, where we are going to do a sum based on the income. So income field is used. This will give the sum of persons whose income is greater than $4 million. So we got $13 million. Match first. As you can see, we have 5 million and 7 million. So the result is 13 million. The sum operator is used on the income field. So $income is a field. So that is a key point to note. We have used greater than. So we got 13 million. Now let me use less than here. On running this, the result is 680,000. Let me do a match on this to demonstrate. So we have 2 incomes, 290 plus 390. So it adds up to 680. Do always remember to see and understand the diagram in the documentation. It gives you a clear idea about how aggregation works. So we have covered all the basic topics. The basics is done, the simple CRUD operations is done, capped collection we have seen, TTL we have seen, regex, full text search.